All right. Well, thank you for coming. My name is Rob Winch, and I am the project lead for Spring Security. Today we're going to be talking about enterprise security with Spring Authorization Server 1.0. We're going to go ahead and give you a chance to get the source code and slides if you want. This will be available later as well. But I'm also going to give you a quick agenda. So we'll talk about our motivation for using an authorization server, and in particular for using the Spring Authorization Server. Then we're going to highlight the auto configuration that Josh Long talked about in the keynote that comes with Spring Boot and the new Spring Authorization Server 1.0. And then we're going to talk a majority of the time about how to make your authorization server or Spring Authorization Server enterprise ready. All right? And if you didn't get that link, don't worry, it'll be available at the end, and then you can get it through the typical channels as well on the website. All right, so why do we need an authorization server? And a lot of times I hear people saying, I don't actually really need an authorization server because I have basic authentication. And that sounds great because basic authentication is very basic and it's easy to set up. But there are some drawbacks to it. And, first, let's just see how easy it is to set up a basic authentication application. So I've already set one up. And there's, it's just your typical, let's see here. Try to get this a little bigger for everyone to see, maybe. Let's see, hold on one second. Oh, shit. No, it's not, do it this way. Well, we're gonna, Josh Long, IDE expert. How do I get this bigger? It's not.
File preferences, and then there's a appearance. Look for the word font. Actually, just go to settings and look for the word font. There you go. That works.
Yeah, I think this is only temporary for some reason, but we'll use this method.
Go to your settings. You can make it permanent. You want to look for IDE font or something like that. Editor font. Go to settings, or just command. Yeah, settings. Like a third one.
There we go.
And then look for font. I think that's the IDE. You want your editor. Go to just search for the word font there. Yeah. Font.
Just font.
Font. Yeah. There you go. Try that. 13.0.
Okay, thank you. Earlier, the keyboard shortcut was working, and now it's not, so I'm not sure what the deal is. Okay, that's great. Thank you, Josh. All right, hopefully you can see that in the back. But basically, you're just having the typical Spring Security starter, and nothing super fancy there. And then we have in here also a message controller. There's nothing security specific about this, but this is what my application is. It's just saying hello to the currently logged in user. And then we have the application here, and it did not seem to impact that one. So I'm not sure why it doesn't impact everything. We're just gonna roll with it. That's our application. There's not a lot to be with it, and I can authenticate with it, and it says hello user. So why is this a problem? It is super easy to set up. What is it with this application that makes it that why can't I just use this in production and forget about OAuth? Well, to understand that, you need to know a little bit about passwords and how they're stored. And to understand why they're stored the way they're stored, we need to know a little bit about password history. So back in the day, it used to be perfectly acceptable for people to store passwords in plain text in a database. And the thought for that was that the password is stored in the database is protected by a password. Who cares? No one's going to access these passwords. Well, we know how that goes. Someone gets an SQL injection attack, they dump the database, get access to all the passwords. what compounds this problem is that everyone reuses passwords. And it's getting a little better today, but especially back then and still today, people reuse passwords. So if they get access to one password, then you're going to get access to the password that people use for all of their accounts. So we got wise to that situation, and we decided to run these passwords through a hash first, like MD5 or SHA. And instead of storing the password in plain text, we stored the encoded password or the hashed password. And this was nice, but the problem with that is that attackers got wise to this as well. And instead of computing the password hashes once when they're trying to crack it, they would build these lookup tables called rainbow tables. And the rainbow table just said, given this hash, this is what the original password was. And so they were able to look it up very quickly. And we improved a little bit on that, and we decided to use something called salt. Salt is just a random set of bytes that is combined with the password, and then that is ran through the hash, and then the random bytes are stored alongside the password. And what that means is, rather than the attacker being able to store the password lookup, they'd have to do every permutation of these random bytes plus the passwords, which made it impossible for them to do because there were so many combinations. But in modern day hardware, we can crack a password in less than a second. And that's on a CPU, let alone on a GPU. And that's when you're using a cryptographic hash such as MD5, SHA-256, etc. So nowadays, what we want to do is we want to use a one-way adaptive function. A one-way adaptive function is something like PPKDF2, bcrypt, scrypt, Argon2. These are all options that you can use for storing your passwords. But what's unique about these is they're intentionally resource intensive. And I say that because a lot of people are like, why is it so slow? Intentionally resource intensive. And the reason for that is because otherwise someone's going to crack it. And how do I know that it's actually working? Well, you should be optimizing it to be about 1 second for a password to validate. And you might say, okay, well that's great, but that basic auth example that you just did was faster than 1 second. Why was that so fast? And the reason for that is because Spring Security is a framework, and it doesn't actually know how fast your hardware is. So we took the minimum recommendations from OWASP, which is a work factor of 10, and we applied it to our defaults. But for your applications, you should go in and check to see, are my passwords optimized for my hardware? And we'll take a look at how to do that here real quick. You can see down here at the bottom I have a password encoder, and it's taking a work factor parameter, and all that's doing is encoding the password as Spring would want to see it with a given work factor. And then we have another function here that just outputs how long it took to generate the password. And then I have an all method here, which will run through a series of work factors. And you'll see that this is starting up, and it's almost instant for the first ones because there's such a small work factor. But you'll notice that as it's increasing, it's taking about twice as long each time I increase that work factor. And I know what you're thinking. You're thinking, oh, well, why don't I just make it really, really big? Well, the problem with that is if your hardware is taking a really long time to validate a password, say 10 seconds, then you're making your users wait too long, and then also you're making it so that it's easier to do a denial of service. So you do want to kind of optimize for that around that 1 second mark, which is the recommendations. And you can see the 14 work factor of 14 is about what I want for my hardware. So you can do the same on your production hardware and see what should I be doing. Now going back to our question of why shouldn't I use HTTP basic and not something like OAuth? Well, the reason for that comes back to how we're storing our passwords. If every request is taking in a username and a password, and every request is going to take 1 second for validating the password, our service is going to be at best 1 second. I don't know about your SLAs, but I don't think that would fly with very many people's setups. So you can't really do that if you're storing your passwords securely. So what is the solution? The solution is that you need to exchange your username and password for a short-term credential. Long-term credential, exchange for a short-term credential. In a typical web application, that might be a session ID, or if you're doing something like an API, you might exchange it for an OAuth token. Does that make sense? So basic auth is kind of out just by design because of the way that we're storing our passwords, and if we want to store them securely. Okay, and this is just a nice little graph that talking about exactly what I was saying earlier. As you increase the work factor, it basically doubles. So another thing that I see people talking about is if I don't do basic auth, I can just do a very simple JWT-based application. So let's see how we can do that. Instead of doing full-blown OAuth, I'll take my username and password and I'll exchange it for a JWT. While that's starting up, we'll take a look at our configuration here. And there's nothing really that fancy about this application. It's any request is authenticated. We're disabling cross-site request forgery. And when is that safe? I get that question a lot. If you're not in a browser application, you can disable cross-site request forgery. If you're in a browser and you're asking that question especially, do not disable it. So if you ask the question, that's usually a sign that you need it enabled. But the other thing is if you're in a browser. So we're not going to be using a browser for this application. Basic auth is enabled so that we can exchange the username and password for a token. We enable resource server, so this is how we're going to validate our JWT once we created it. And we customize the exception handling to act as though they're bearer token responses. Here you see that I have a user, and their password is just password, decrypted with a work factor of 14. You can see that there. And then we have a JWT decoder. A decoder is how Spring's resource server support is going to validate the JWT token. And then we're auto-wiring in a public key using JWT public key. Where is that coming from? If you look in my application YAML, I just chose JWT public key. Doesn't matter what you call it. You could call it something better. I am similar to Josh with my naming, so you might come up with a better name. But it automatically transforms this class path app.pub into a resource. And then that resource gets transformed into, we went through that at the beginning. It can't get bigger. It doesn't stay bigger for some reason. Yeah, so the class path automatically turns into a resource. And then the public key, it turns into a public key and a private key. And so that's basically how that's happening. Then we're going to use the token controller. So this token controller is accepting an authentication object. And that authentication object is there because in our configuration we saw earlier that any request must be authenticated. So if any Spring Security is already making sure that happens, that means our token, in order to access this, must be authenticated. So we get the authentication object, and then we turn it into a JWT. So our controller is what's creating the JWT, but Spring Security is authenticating the basic auth, and then it returns a JWT in the response. And once it returns that in the response, we can use that to make additional requests to our hello controller. And now we can go ahead and try that. We'll do 8080 token. So I just have a little shortcut here where I'm extracting out the OAuth token into a variable, and then I echo it out. And you can see that takes quite a bit longer now that we've optimized our password. And then we want to be able to, we want to be able to get our messages. So now I can get my message. And you can see that getting the message itself is much faster now that we're using the JWT. So it is a lot faster. And that's good for us because again, we don't want to take 1 second on every request. So you might say, OK, well, this is great. I'm just going to use this simple JWT approach. But I'd argue that this still is not an ideal setup. First of all, our passwords are happening on the same set of hardware that our regular application is happening on. We really want to distribute that workload. And another thing that I'd argue is that with the new authorization server support, it's actually easier to set up a full-blown authorization server, and developers it's well documented how to use OAuth as well. So you're going to get a lot of advantages from that, and it's just as easy. So let's take a look and see how we can use a full-blown authorization server. All right. Here we go. We have one set up already, and in here we have our OAuth 2 authorization server starter, and you'll see that I have a few extra dependencies at the top. I'm just calling attention to that because you don't need that for the getting started experience, but so that we don't see the internet crawl as we update our dependencies throughout the presentation, I've added them ahead of time. So know that they're needed for later on, but not the getting started experience. And then I have a typical main method here, and then we have our application YAML. So our application YAML, it has a client secret or a client ID of Spring. And then we have a secret of secret that's using bcrypt and a work factor of 14. Again, as we discussed, that's what my hardware is capable of handling, so that's what we want to do. And then we'll skip over some of this configuration down to our redirect URIs. You'll see I'm using 127.00.1 rather than localhost. And this is one of the things that I see people get tripped up on. If you're in a browser and it's using cookies, and you have two applications running on different ports, cookies are not unique by port. It's only by host. Strange, but true facts. So if you use 127.00.1 for your client and localhost for your authorization server, your browser won't get tripped up on which cookie is which, and you won't have problems. So just calling that out so that people don't run into the same issues that I see lots of people running into there. And then at the bottom here we have password of password, again bcrypt with a work factor of 14. Once we've done that, we can start it up, which we've already done, and we can go ahead and try to get an access token. So we'll go ahead and get an access token here, and I have one. And then I can use it on a resource server. And I get hello. That was really easy. I stood up the authorization server, just a little bit of configuration, and everything's working. So how's that resource server working? It's just using the standard Spring security support. So to do that, you just need the starter. Starter is the resource server starter. And then we need just one configuration property, the issuer URI. And some people are like, well, how's that help? What is that actually doing behind the scenes? Well, behind the scenes, it's really just doing a lookup of a well-known endpoint. Based upon the issuer URI, you concatenate this well-known endpoint that's published standard, and it points to a set of configuration. And you see this configuration here. There's a lot of endpoints here, but right now we're really interested in this JWKS URI. The JWKS URI is an endpoint that shows the keys for our authorization server. So there's two things that I'd like to point out here is we have this KID, or key ID, and it's just a GUID, and then we have a public key that's exposed here. This is automatically generated using the Spring Boot auto configuration. So it makes it very easy for us to get up and running. OK, so we can see how we can easily set up the authorization server for resources. Let's also see that we can use this exact same setup in a client-based application. And for that to work, surprisingly, I have to start up the resource server. So I couldn't start that up because we're using the same port as we were earlier. So now we'll start that up, assuming that I remembered to turn off the last one. Yep. All right. There we go. We'll just log in as user and password. And it wants our consent, so we'll go ahead and consent to it. And it's just going to say hello. The application is very basic. So we're able to set up a use our authorization for not only a resource server, but also for a authorization code flow in just a few easy steps. And I would argue, again, that this is actually even easier than the simple JWT application that we looked at. But this does leave a little bit to be desired because it's not quite production ready. So the first step, I think, to making some of these things production ready, in particular our authorization server, is to kind of take a peek behind the covers and see what is that auto configuration doing. And in order to do that, we'll just reset our branch to here, and then we'll take a look at what that configuration looks like. So I was able to just pull this up by resetting my branch, and you say, well, where'd this come from? That was, that was really hard. How am I going to know where this is coming from? Well, the good news is this is all documented, and I guess the internet stopped working. OK, well, just take my word for it. You can always trust me. I'm a security guy, right? It is documented, and it will be in those links. You can get that configuration from there, but I've kind of distilled it into something for our particular example. Now, I'd like to point out that there's two different security filter chains. The first one is kind of for OAuth endpoints. And what it's doing is it's applying some defaults based upon the authorization server configuration. And then we customize it just a little bit by enabling OIDC support. We also add a little custom exception handling to send us to the login URL if no one is authenticated whenever we request an access token. And finally, we also enable resource server support so that you are able to access things like the user info endpoint when doing OIDC support. Finally, we have for the rest of the application. So again, this is kind of like a two-stage thing. This is all the OAuth endpoints. This is the rest of your application. Any request needs to be authenticated, and we're using form-based login. And you might say, well, like, how can I learn more about what these security filter chains are and how they work and how they, I need some diagrams. And I would show you the diagrams, but the internet stopped working. But again, you can trust me. I'm a security guy. They're on the internet. And you can get those just from the Spring Security Reference Manual. All right, so we've got a good starting point by seeing what the out-of-the-box support is providing. How can we customize our login? And I just got in the requirements for our custom login, and our custom login is that we want the exact same thing, but we need it green because spring green is beautiful, right? So sounds like a pretty ridiculous requirement, but I've heard of more ridiculous requirements. And this should give you a very good starting point on how to customize your login page and your security configuration as well. So all we really do is we say form-based login, and we provide the URL of login. And then we also say that the login URL must be permit all. And that's just saying, if I'm not authenticated, I still want to be able to access the login page. And then we have a login controller that returns the login view. And then we have this login page. And this login page is pretty much the exact same thing that we saw earlier. The same markup. It's doing a post to login, providing a username and password, and then we change the background to green. If we start this up, we have to log out first. So that's our client application, which we did not restart. Now our authorization server, we have our green login page. And again, you probably will want to customize this to your own needs. And we'll skip logging in for that step, but it still logs in. The only thing we changed was what the UI looks like. And so that's really good, but the next thing that we'd really like to be able to do is we'd like to be able to store our registered clients in a database. Earlier, we were putting it in our application YAML, so I've removed that now. And I'm instead doing it in a database. This makes it a lot easier if you have like a distributed environment and you're standing up multiple instances. I have this JDBC registered client repository, and that's provided out of the box with Spring Authorization Server. And all I need to do is inject a JDBC template with a data source. And then there's one other bit. At the top of this class, we document that you need a schema, and the schema is provided as a class path resource. And so then I just update my application YAML to update that when I start up. So once again, if I start this application, if I start up the application, it's going to give a bad request. Let's see. There we go. And you have to type the password correct. Security is working. Consent to the page, and then I see my simple hello app again. So all that's working still, but we still have some more steps to get us to production. So we want a custom consent page, just like our custom login page. We want that to be green as well. And again, you might have different requirements around the consent page, but this gives us a good starting point for how to set that up. And I think that's actually the reason I restarted the wrong app. There we go. In our security config, we have, did I not reset that? All right. One second here. Huh, there it is. I don't know, it looked like it was there, but it wasn't. All right, so we have our custom consent page. Again, our top set of configuration is our authorization server. So any of our OAuth endpoints, you're going to look for customizations in there. And I just provide the OAuth consent page. And just like earlier when I provided the custom login page, I need to do the same thing. I need to resolve that endpoint with the consent page as well. So I go into here, and I have a consent controller. And again, you might say, well, where is this coming from? There's a link at the top that'll take you to sample applications that kind of show you how to do this. But for the sake of brevity, I'll just go over this real quick. We have a scope parameter, a client ID, and a state. Those are all provided in the redirect URI. And we use that along with the authorization consent service to provide the consent screen model. And then the UI is here, and we've provided a green background for that. Again, it's pretty much exactly what you saw out of the box. You'll have your own custom requirements, but this will just show you how you can get it up and running for your application and a good starting spot. So while that restarts, we'll log out of this application, and we'll see that if I log in now, we get a green consent screen. And the other thing to point out is let's see. There we go. I think it had an invalid state with the cross-site request forgery cookie in there because I started it halfway through. But basically, the other thing that's important to point out is that this JDBC OAuth 2 authorization consent service is another thing that we did in this step. And all that's doing is storing the authorizations in a database. Again, you want to do that if you're doing a distributed application. All right, so what's our next step on our path to production? We have a authorization JWT OAuth Authorization Service. And again, this is not anything too difficult or exciting, but it's necessary in order to make this enterprise ready. Again, this has documented the class path resource for our schema, and we've updated that as well. And we also have that defined as a bean in our security configuration. And it requires a registered client repository, just like our consent service did. And once we do that, we restart the server. Everything will still be acting as we saw before. Logging out. I should make the password easier to type. There we go. And we're logged in. All right, so we've seen how we can do all this, but there's still kind of a big problem with being ready for production. And I mentioned this earlier. Our keys right now are dynamically generated at startup time, which makes production really easy, or not production, but development really easy. But what happens if you have more than one instance, right? If you have one instance starting up, generating one key, and another instance generating another key, you might get an access token generated with one token and a resource server trying to validate with another key, right? So how do we make these consistent? Well, we're going to start off by taking some hints from our simple JWT service that we had earlier and set up a consistent key using, I keep doing it in the wrong UI. Let's do it in this one. I think it doesn't refresh if I don't do it in the correct instance of the browser, or correct IDE window. All right, so now we have that. And let's see what we have. We have a JWT Source. This should look very familiar to what we saw earlier. Again, we have the JWT key ID. We have a private and a public key. All of those are configured in our YAML file. And you'll see that my ID starts with configured. And I did that so that you would notice that it's now configured rather than being generated. And then I have a public and private class path resources for the public and private keys respectively. And those resources are available on my class path. So now that I've done that, when I restart the authorization server, I'm going to get a consistent key pair for those keys. And you can see now it says configured, right? So it's working. Now, you say, OK, that's great, but one of the other things that I'd like to do is be able to rotate my keys. Wouldn't it be nice if we could rotate our keys with 0 downtime? Well, let's take a look at our resource server and see if that supports it first. So the resource server, we're going to get an access token. Get an access token from here. And I just copied that to my clipboard automatically using the script that I was pasting in there. Oh, and this is, OK, I think that's just what got cached because the internet's not working. But if we took a peek at that JWT token, it would show that this is actually using the new KID, so the key ID of our configured key ID is in that token. We can't inspect it right now, but now I will go ahead and use that to access my resource server, and it's still working. Even though I rotated the key, resource server is still working. And in fact, I haven't restarted it the whole time, so we've been restarting it and trying it again, and everything is still working within that resource server. And the reason for that is it's just using that endpoint that we saw. It auto-discovers the endpoint based upon the issuer URI, looks up the JWKs, and it figures it out based upon the key ID passed in. But our authorization server right now, we don't really have a good way to rotate it. So what can we do to make that so that we can rotate the key without having a downtime. Let's take a look. Let's see. All right. So there's a bit that we've added this time, but kind of the central part of this is a JWT source. We've talked about this in a couple of different sections, but the JWT source is Nimbus's entry point for how to create and validate JWT tokens. And what it does is it says, given a selector, we'll go over that in a minute, but and a security context, which this is Nimbus's security context, not Spring Security's. Give me a list of JWTs that I should display. And what we're doing for this is I've created a key pair repository that finds all of the keys. So there's an RSA key pair object. It just has an ID, when it was created, public key and private key, and it returns those in a list. And we have a couple other methods, a delete and a save method. Now, I did cheat. I did an in-memory implementation, but you can easily change this interface to be something that you guys want. You might want to be doing it in something like Redis if you're trying to look up things very quickly. You might have a NoSQL store of other types, or you might just put it in JDBC. All of those should be pretty easy to implement. But one thing I want to call out is that I'm returning these sorted by the created date. So the most recent versions are returned first. And why is that important? We'll get to that in just a minute, but I just want you to remember that the more recent ones are going to be first. So the other thing that I had to do is I updated my security configuration. So the security configuration is we're exposing a Nimbus JWT encoder, and we saw that in our previous examples, a previous example. That's how we're creating the JWT, and Spring's authorization server support will pick that up. But we're actually overriding the component that uses that as well, called the JWT generator. And the generator is basically what is using the JWT encoder. And why did we override that? Well, we're providing this customizer. And the customizer is I've also implemented in this JWT source. And what it's doing is it's saying, if you're looking for a key pair, prefer the key ID of the first entry. So that means when we're creating a new JWT, always encode with the most recent version. So that's how we're rotating. If we add something to our repository, then it's going to use the newest version. However, if we're displaying all of them will still be displayed, and the resource server can still validate. The idea is that after the tokens are expired, you can start deleting some of the older ones. But you don't want to do it before then unless you want to end it faster. Maybe the key got compromised or something. OK, so now that we've done that, what else do we need? Well, we also need to update our security configuration just a little bit to change our authorization. So what I've done is I said, I want to have the scope of keys.write for the JWTs endpoint. And that just says you need this an access token with special permissions in order to update that endpoint. Finally, we have a keys controller. And the key controller basically has a post mapping to generate, and it generates a new key pair, and then it saves it to our repository and returns the key pair ID. Make sense? So now that we've done that, we should be able to restart our authorization server. And we'll take a look at our endpoints here. So we have our JWTs, still our configured entry. That's how we're initializing it. And then we can still go ahead and generate a access token, so we'll do that. We can still use it on our resource server. And then we can also generate a new access token with keys write access. And then we can use that to update our token. So we'll do 9090. It's in this history somewhere. There we go. And so it generated a new token, and this is our new key ID. Remember, we're returning that in the response. So now that we've done that, we can look at our JWKS URI. And you can see now we have configured, which is listed second, and we have keys, which is a new key, which starts with 400 listed first. So we've updated those. Now a resource server that is receiving a new access token will see that new, if the key is generated with the key ID of 400, it will be able to retrieve that entry as well. So now if I generate another access token, from here, we can use this access token to access our authorization, and we still get hello. So now we're able to rotate our keys without having a downtime. You can add like a UI if you wanted to it, and delete the keys after you're done with them. Add like automatic expiration to it, have it cleaned up. There's a lot you can do with it, but this is a really good starting point for you to figure out exactly how you can get that automatic rotation of your keys and how to put those pieces together. All right. I want to open it up for questions so that we have some time to do those. And I'll go ahead and run it on this rather than the questions slide. Before we get to the questions, though, I wanted to just open it up. If you see me, I'd love for you to come say hello to me, and love to talk Spring, security, or just anything you care to talk about. I'll be at the Spring booth after this presentation, so if you want, you can see me there, or if you just see me walking around, come say hi. I'm also on the internet for Twitter, yeah, that's pretty much all I have, but I'd like to open it up for questions first. Anyone have any questions? You, please.
So, is it possible to dynamically customize the JWT, depending on, for example, user, roles, or whatever, just inject the scopes?
Yes, so the question is it possible to dynamically customize the JWT? And the answer is yes, there's a customizer that you can use to do that. Yep. I think I saw a question back here, or maybe that already covered it. Any other questions? Yes, sir.
How do you do the token invalidation? You showed us the logout. Is it just removing it from the front end, or are you actually invalidating them too?
So I wasn't hearing that repeat, so I'm just going to repeat the question in case someone didn't hear it. But the question is, how do you do token invalidation? And if you look at, we didn't cover that, but if you look at our well-known endpoints, there is a, let's see, there is a revocation endpoint. So you can use that to revoke it. Now, obviously, when you're using JWT, which is stateless, you're kind of introducing a state to that. But there's also support for opaque tokens as well in Authorization Server. So you could switch to an opaque token if you wanted as well. A good question. Any other questions? Yes.
Thank you. How do you implement session management? Maybe I missed that.
The question is, how do you implement session management? Is that correct? Are you referring to like session management in terms of how many users are logged in, how many user time, or? Okay. So I think I think the question is around like HTTP session, like the session within the servlet container. How do you make that highly available? Is that the session management you're talking about? Okay. Yep. Yeah, so there's a nice project called Spring Session that will do that for you. And you can just enable that. I'd show it to you, but the internet's not working. But yeah, you can just Google Spring Session. And kind of the de facto standard for that is using Redis as your backing repository, but there's different repository backings for that project as well. Yes?
Okay, and try without microphone. Thanks, Rob, for your presentation. Great stuff. In your last example, you showed us how to create new keys, like with the endpoint. But those keys, as I understand, are not distributed, right? So if we scale again, we have the same issue that you have multiple keys on different instances, right? So how would you approach such a use case for key rolling and scalability?
So the question is, in my last example, the keys were not distributed across multiple project instances of the application. So how would I solve that? And I probably didn't make it very clear, but we have here our let's see, we have our we have an in-memory key pair repository. So this is just an interface that we're using. You would create one that stores it in a database. I did take a shortcut and do it in memory, but I'm kind of leaving it to the rest of you to put it in a database, mostly because when I timed the talk, there wasn't enough time to do something like that, and also because many people are not necessarily going to use the same data store. They might use JDBC, they might use a NoSQL data store, and they might have, there's like at least a dozen choices on NoSQL data stores as well. So you're probably going to re-implement that interface anyways. Does that make sense?
Thank you, Rob.
Yep. Yes, please.
Is it possible to combine the authorization server with another third-party authorization like Google login or Microsoft login to just go through?
Yeah, so the question is there a way to combine the authorization server with a third-party authorization server so that you can kind of add like a chain of authentication amongst them? And yes, there is, because if you look at our security configuration here, if you look at this for the authorization server, right now I have it configured for form-based login, but I could use an OIDC, or I could configure it with LDAP, or I can configure, it's basically your standard security configuration at that point. So you can do anything you can with Spring Security or customize it with anything that you normally would with Spring Security. So good question, good question. Any other questions? Yes, ma'am? Oh, I think, sorry, see if the mic works now.
What if the provider is not OIDC compliant?
What if the provider is not OIDC compliant? So Spring Security has kind of a support for an OAuth client that's just doing, it's kind of like an ad hoc OpenID Connect, where you plug in your own user info endpoint, and it doesn't have to be compliant. It's just basically turns the REST API call into a user. So you can actually plug into non-compliant providers as well from the OAuth client side.
Thanks.
Yes, no problem. See a question back here?
Thanks. When storing the keys in a database, is it okay to store them in plain text there?
So the question is, when storing the keys in the database, is it okay to store them in plain text? And the answer is, for the public key, yes. For the private key, no. And you know, there's going to be different levels of security that you're going to want to put on those keys. But you know, that kind of goes back with the whole discussion around where do I want to store these. Like, you might store them in HashiCorp or something like that. Like, you might store them in something that's intended to store keys. It really depends on on your deployment setup, but you do want to take precautions around how you store those keys. And a lot of times the vendors are going to do a better job than I say vendor, it could be an open source project, but projects dedicated to that sort of thing are going to do a better job than a developer adding their own custom encryption on top of that. Because encryption is, it's not for the faint of heart. I think we have time for one more question. Right up here.
Hi, good talk.
Thank you.
Is there some reason that you talk more about repository saving the key, but not about secret manager?
So the question is there a reason why I talk more about the repositories rather than secret management? We talked a little bit about the secret management with storing your secrets using bcrypt and like optimizing that. But this talk was really supposed to be focused on authorization server, and storing secrets is kind of like a probably a broader topic, like I could dedicate a whole talk to on its own. So more around like timing and focus is probably the answer to that. If you want to talk more about storing secrets, I'd love to talk to you, like after, I have to give up the stage for now, but I'd love to talk to you afterwards, or catch me in the hall or something like that.
But not specific reason.
No, basically just the focus of the talk was more on the authorization server specific stuff. Yep. All right, well, thank you everyone for coming. I really appreciate you attending my talk and hope to see you around.